Hi everyone, I'm Andrei Mihai, and here with us is Dr. Paula Moraga, the 2023 recipient of the Letten Prize. We're going to be spending about 30 minutes discussing her work and what she's contributing to science and society in general, after which we'll be taking questions from you people in Zoom. If you have any follow-up questions, drop them in chat at any time and I'll do my best to read them. And if not, we can pursue them at the end of the conversation. I'll start with a short introduction. So the Letten Prize aims to raise public awareness on how research can be used to solve global human development challenges. And Paula Moraga's work is an excellent example of that. She has a background in mathematics. She obtained her PhD from the University of Valencia in Spain, and she's held several positions at institutions in the US, UK, Australia, and Sweden. And currently, she's an assistant professor at King Abdullah University of Science and Technology, KAUST, in Saudi Arabia, where she leads the Geospatial Statistics and Health Surveillance Research Group. Her work focuses on geospatial health, and she's been a pivotal figure in pushing the boundaries of this field, but also on policy implementation. Her work has had a tangible impact, leading, for instance, to interventions that curb the spread of malaria in Malawi and reduce cancer inequalities in Australia. She's also a fervent advocate of open science and reproducible research, and she's actively publishing tools and tutorials for other scientists to use. So, Dr. Moraga, congratulations on winning the Letten Prize. How are you today, and what was your reaction on learning the news?
Well, thank you very much. The thing is that I'm really honored and grateful to receive the Letten Prize to continue my research in disease surveillance. I would like to thank the Letten Foundation, the Young Academy of Norway, as well as my collaborators over the years. Professor Letten believed that health, environment, and equality are key to a better future for all, and to be honored in her name is a wonderful privilege.
That is lovely to hear. Could you please start by describing the body of work, just in summary, that led to this recognition, and what is the main focus of your work now?
Yes, so my research focuses on the development of statistical methods and computational tools for geospatial data analysis and health surveillance. This includes methods to understand geographic and temporal patterns of diseases, identify disease clusters, and early detection of disease outbreaks. So now I'm working on a digital surveillance system. Surveillance systems are critical for the early detection of epidemics and the design of control strategies. But traditional surveillance systems have a limitation, and is that information is delayed. From the time that the person gets sick to the time that the person decides to go to the doctor, goes to the doctor and have the laboratory tests, it may take a few weeks. So this information is not useful for taking action in real time. Nowadays, we have access to other types of data, for example, social media data, where people chat about how they feel, or Google searches, where people search treatments for their conditions. And this information is not produced for epidemiological research, but we can use it to understand disease activity levels in real time. And we also have access to environmental, climatic factors such as temperature, precipitation, that also affect climate-sensitive diseases. So my objective is to develop a disease surveillance system that integrates multiple data from different sources, official disease data, climatic data, digital data, to produce local probabilistic forecasts of disease activity in real time. So I will develop an open source software with a dashboard with interactive visualizations and reports that will alert public health officials when elevated disease levels are anticipated. And this system can also help to design strategies for disease prevention and control, and to allocate resources in areas of greatest need.
So, zooming back a little bit, tell us about your journey and how you got started with this field in the first place, coming from a background in mathematics.
Yes, so I studied mathematics in the University of Valencia in Spain. I studied mathematics because this was the subject that I enjoyed the most in high school. But then in the university, I discovered that mathematics, statistics, programming could be used to solve real-world problems. So then I decided to start a PhD, and during my PhD, I worked in the Register of Cancer in Spain, developing methods to understand geographic patterns of cancer and identify risk factors. But then I realized that I didn't have enough epidemiological and biostatistical background to do that because I studied mathematics. So what I did was to apply to a scholarship to go to Harvard and study a master's in biostatistics. So I completed the master's, then I came back to Europe. I did a research stay at the European Center for Disease Prevention and Control in Sweden, and I finished my PhD. After that, I had several statistics positions in several universities, working on spatial epidemiology and modeling. So I worked at Lancaster University in the UK, then I went to Harvard in the US, then I came back to the London School of Hygiene and Tropical Medicine, then I went to Australia, to Queensland University of Technology, then I came back to the University of Bath in England, and now I'm in KAUST at the King Abdullah University of Science and Technology. So in KAUST, I lead a research group, and we work on geospatial methods for health surveillance. So during my career, I have developed methods to understand spatial and spatiotemporal patterns of diseases, identify risk factors, and detect clusters. And I have also developed a number of R packages for Bayesian disease mapping, detection of clusters, and risk assessment of travel-related spread of disease.
Starting a PhD and starting a different course, almost like a side project to your PhD, must have been super challenging. Do you think this multidisciplinary experience that you gained then was so important in your career? Was it worth it?
Yes, totally worth it. And I've also worked in several projects in collaboration with epidemiologists, computer scientists, entomologists, and I have learned a lot from different fields. So it has been a very enriching experience. And also, what it did is, for me, I became a better data scientist, because now I don't just analyze data. I also think about the process of collecting the data, what are the limitations and the biases of the data, what are the best approaches to analyze data. And also, when I need to communicate the results, I also think about ways to communicate these to collaborators and policymakers in an effective way.
It's a very applied field of research. Can you provide some specific examples of how your work has already directed or at least informed policymakers?
Yes, for example, I can tell you about a project where we assessed the effects of interventions to reduce malaria transmission in Malawi. Malaria is a disease that is transmitted by mosquitoes, and in the last decades, the burden of malaria has reduced a lot, thanks to bed nets, indoor spraying, the use of anti-malaria drugs. But in the very few, the last years, we don't see any decrease anymore of the burden. So we wanted to assess additional interventions to see if these interventions could further reduce malaria transmission. One of the interventions was house improvement, and the other was larval source management. House improvement consisted of going to the houses and closing all the holes, all the windows, all the doors, so mosquitoes cannot enter. And larval source management consisted of going to the water bodies and applying larvicides to kill the larvae. So we randomized villages to 4 groups. One of the groups received both interventions, another group only house improvement, another group only larval source management, and another group none of the interventions. And then periodically we went to the villages to see the abundance of the mosquitoes using traps, and also we tested people to see if they had malaria. And we found out that these interventions were having an effect in some of the groups. So to communicate these results to the villages, to the people living in the villages, what we did was to go there with a team of researchers and also local population that spoke the local language. And we conducted several activities such as games, football matches, music, and it was a very nice day where we could very easily talk about malaria, the risks, and how they needed to modify their behaviors to avoid getting infected and to reduce the risk of malaria. Also, another project I was involved in was the development of the first atlas of cancer in Australia. So this atlas is freely available online. Everybody can check the atlas, and it's very useful for policymakers because they can identify high-risk areas and also which are the most vulnerable populations. And this helps them design campaigns where they can educate people about cancer, their possible causes, and it's also good for the general public because they can be informed about this disease.
This field of research has been given a lot more attention, or at least public attention, with the COVID-19 pandemic. How has your work sort of changed, or how has it been affected by the pandemic? Is it receiving more attention, less attention, more funding perhaps, or is it all the same?
Yes, I think people are now more aware about disease risks because we live in an interconnected world. Human health is connected with animal health and with the environment. There are many diseases that are spread from animals to humans. For example, vector-borne diseases such as malaria and dengue. There are also there are also other diseases that emerge, like because the development and human activities, for example, deforestation is putting wildlife in contact with humans. Climate change and increased temperatures are causing that diseases that usually occur in tropical and subtropical regions of the world are now occurring in new areas. And also global travel is making that diseases spread globally. So I think now everybody is more aware about disease risks, this connectivity, and that we need to work together to protect our planet and also to minimize the consequences of future global threats.
And you also mentioned that you communicated your findings to the public, to the beneficiaries, let's say. How did they react in your experience? Were they receptive to your findings? Were they curious or interested at all?
Yes, so the thing is that we do research because our objective is like improve the world and improve how the health and the well-being of the population. So it's very important that we communicate our results to policymakers and also to the general public, so we can get feedback as well about what they think, what we need to improve, because at the end we do this to benefit the population. So they are very receptive to hear what we do.
And you also publish a lot of open science related work. You publish packages, you package apps, to all sorts of tutorials, videos, which is quite inspiring and useful for other scientists, because as you mentioned, many people in mathematics or statistics may not have the knowledge, and many people in health may not have the mathematical knowledge. How do you see your work in this sort of field, and how do you see open science contributing to society in general?
Yes, so I also develop software, so my methods can be widely available and provide benefits beyond my own applications. So I have developed methods for Bayesian disease mapping, detection of clusters, and risk assessment of travel-related spread of disease. Some of these packages are used by people that, as you say, maybe they have the data, but they don't have the statistics or programming skills to analyze the data, so they can use these tools to analyze the data. Or other times, these packages are used by people that maybe they are proficient in programming, but what they want is to build upon these tools to produce their own tools that are appropriate in their own settings. And also my training tutorials and my book. I have a book that I published and is freely available online about the spatial health data modeling and visualization, and is impacting learning on a large scale. Yes, I see the impact of these tools and these tutorials because I see that these works are cited in scientific publications. And also because sometimes I get contacted by people that are using, for example, PhD students that are learning new statistical techniques by looking at the examples in my book, or also professionals that work in research institutions and are using the tools that I developed. For example, there are researchers in Canada that are using the tools to map cancer in Canada, and also researchers in Costa Rica that are looking at the risk of zoonotic diseases in their country.
And you're also a member of the epidemics consortium, or RECON. Could you tell a bit about your work in that project and sort of how you're making and how RECON is making a difference in general?
Yes, so RECON stands for R-Epidemics Consortium and is an international group of people that work in global health. There are statisticians, modelers, mathematicians, computer scientists, and we develop tools for disease outbreak response using R. R is an open source software for statistical computing and visualization that is freely available online, so it's accessible by anyone. And we develop tools to manipulate, analyze, and visualize epidemics data. For example, I was involved in the development of a package called EpiFlows for risk assessment of travel-related spread of disease. So, as we all know, infectious diseases may spread beyond national borders. People living in one location can go abroad and infect people abroad. And people that come to the infectious location for holidays, for example, can get infected. And when they return to their home countries, they can infect people in their home countries. So this package implements a mathematical model that predicts the number of cases that could be spread to other locations together with uncertainty measures. And it uses population flows, lengths of stay, number of cases, incubation period distributions, and it has been used, for example, to calculate the spread of yellow fever in Brazil. We also develop training materials and run workshops, mostly in regions in low and middle income countries, because we think that is important that people are empowered and are able to analyze the data in situations where they need to respond to an epidemic, for example.
From this very diverse body of work, do you have any particular project of the ones you've mentioned, or maybe something else that you're particularly excited about, a project that's close to your heart that you're proud of or happy with?
Well, I'm very proud of the book that I wrote. The book is titled Geospatial Health Data, Modeling and Visualization with R-INLA and Shiny. And it covers how to manipulate spatial data and how to create maps using R. It also shows how to fit and interpret spatial and spatio-temporal models and how to create interactive visualizations, dashboards, and Shiny web applications to facilitate the communication with collaborators and policymakers. The book is freely available online, so everybody can use it, and it has fully reproducible examples, for example, showing how to predict the risk of malaria in Africa, or how to map cancer in the US, or how to predict air pollution in Spain. So it's helping many researchers in a number of fields in their work, and I'm very, very happy to see that it's being useful to so many people.
So the book is freely available. Anyone can download it.
Yeah.
That's fantastic. And on the other hand, do you have any particular challenges that you've encountered in your career of any nature?
Yes, well, I think one of the biggest challenge for people working in data science, at least in health, is the availability of data. Because to solve global problems, we need data, but we don't need just any data. We need data that is reliable, timely, and detailed data, because we need to know how different groups of the population are doing. And for doing that, we need data that is disaggregated by age, by gender, by geographic location, and other characteristics. So during the pandemic, we have seen that it's very challenging to get data, especially in regions in low and middle income countries. But the thing is that if we don't have everybody represented in the data, we cannot address the problems of this population. So it's important that we are able to get good quality data, and we need to improve in this aspect.
And global health issues, especially things like epidemics, tropical diseases, disproportionately affect places like the global south and underdeveloped areas. Is this sort of equity part something that you keep in mind or you try to involve in your research?
Yes, because sometimes like these regions are the regions that need solutions to their problems because they are suffering these diseases and these problems now. But sometimes they lack the human resources or the material resources to address these issues. So I think that by providing tools that they can use that are accessible to everyone, we are giving them the opportunity to improve and to solve the problems. So it's something that we need also to contribute to help these regions that may not have all the materials to do that.
And you also mentioned in the beginning integrating different types of data, things like social media data with health data. And I know that's a big challenge in itself, integrating different types of data, especially so diverse and such an inhomogeneous data set. How do you do that? What's the general approach to it?
Yeah, so this problem arises in many disciplines. For example, in air pollution, you can have that you want to predict air pollution in a continuous, and usually what you have is measurements of air pollution at specific locations because they are given by monitoring stations. And you can also have air pollution estimates that are derived from satellites, but these are given in areas. So instead of analyzing the two types of data separately, what we can do is combine them. And what I do is use Bayesian hierarchical models that assume a spatially continuous random process behind, and I link the points and the areas to that spatial continuous surface. This problem also arises in disease mapping. Disease maps are very important to understand geographic and temporal patterns and identify risk factors. But often, disease maps are given at aerial resolution because data is aggregated in areas for confidentiality reasons. So by looking at these maps, we can see the burden of the disease, but these maps are not very useful for decision makers because in a given region, we only have one value. But in reality, the risk varies continuously in space. So we are also working on methods to disaggregate area level data and produce high resolution estimates that allow to identify locations of high and low risk, and this is much better to allocate resources in areas of greatest need.
And this is something that can also work with anonymized data, or that keeps involved, that addresses also privacy concerns? Can you do that in a way that doesn't affect people's privacy?
Well, ideally, we would like to know the exact location, but as you say, there are many confidentiality issues. But for example, using social media data or Google searches, we need to think first how this data was produced, because we know that not everybody uses social media platforms. only younger people or more educated people do. And also internet penetration is not the same in all places. So if we combine all the data together without thinking about the possible biases, we will be getting inferences that are wrong. So we need to specify models that include random effects to account for these biases and these preferential sampling mechanisms to be able to get good inferences.
Before we start taking questions from the audience, there's just one more thing I want to ask. Is there anything in particular you're excited by in your work or in the field in general, let's say for the next 5 to 10 years?
Well, I'm very excited about the possibility to analyze data in formats that we have not seen before. Because right now, for example, we see more and more mobility data of how people move around. And this is thanks to the wearables and the cell phones data. So we can see how people move around. And this is very important to understand the spread of disease. So I'm very excited to see what other types of data arise and the methods that we develop to analyze this type of data.
Okay. I'm going to ask some questions from the audience, and I apologize in advance for probably butchering the pronunciation, so I do apologize. I'll do my best. A comment from Joyce Omoha, who says that she's been reading about your work, and they're a lecturer in journalism and media studies, and they've learned a lot about open science. No questions, just an appreciation for your work in general.
Thank you very much.
And then Magate Ndiaye asks if there is any strategy or you have any strategy for data quality control and archiving.
Well, I don't know much about this topic, but I agree that it's super important. But like I can tell you from my point of view, all the limitations that the data have, like we have regions that are underrepresented, we have populations that are underrepresented, the time format maybe is not always the same, and there are many errors. So I think this is something that we need to take care about from the beginning. When you are starting collecting data about a specific topic, you need to sit with a group of people to have different opinions from statisticians, from epidemiologists, from people working in hospitals, and design very well how you are going to collect the data. So when you have it, then you are ready to analyze it, and it's what good quality.
Martin de Ambrosio congratulates you on the prize and then asks, what's it like for a mathematician to change the field of research? So how did this process feel for you?
Well, the thing is that in high school, I really enjoyed maths because it was very fun solving problems, like mathematical problems. But then during my degree, people that study mathematics knows that it's very theoretical, very theorems, and I was not enjoying as much in the high school. So that's why I decided to do something more applied, where I could use my mathematical reasoning and my programming skills to do something where I could see the result and the impact in the population. So for me, it was gradual. So I started the mathematics degree, and then I discovered other courses that were very helpful to solve real-world problems, and I followed that path. But being a mathematician, it has helped me a lot because now I know how to think and how to address the problem. So I think it's worth it also to study pure mathematics, and then if you want to do something more applied, then you can do something more applied later.
Do you consider yourself a mathematician, an applied scientist, or sort of a hazy mixture of all?
I think I consider myself more like a data scientist because I like a lot programming, and I like to develop new methods, and I also like to visualize the results. So it's a mixture of everything.
Håkon Sandbakken asks, how do you think AI impacts your field and statistics in general, both in the short term and in the long term?
Well, I think AI is making discoveries and is making a lot of impact as well. To use AI, you need big data sets, because these models have a lot of parameters. While statistical models, maybe they have 10, 20 parameters, AI models may have hundreds of parameters, so you need big data sets. In the field where I work, I don't have enough data to apply these models. Well, in some applications, yes. For example, I do have enough data when I'm working with satellite images, but for example, if I want to estimate the risk of cancer in a region, I have very limited data. So I think AI is very powerful, and it would be great if we combine a statistical theory with AI methods, but also taking into account what is the data that we put in the AI algorithms, because the results are going to be as good as the data are. And the challenges that we have in statistics are the same, are also apply for the AI. So if we want to use AI to predict an outbreak of disease, and we only use data that is collected in a part of the country, we will see the outbreak in that part of the country, and we will not see what's happening in areas where we don't have availability of data. So I think that AI is very good, but we also need to look at the data that we put as an input.
And Niels Halvard Korsvold asks, the Letten Prize is awarded to younger researchers. Do you think that being a younger researcher is a strength in your work?
Well, I don't know if I'm that young, but I'm always, I think young people are very curious, and they are passionate about what they do, and sometimes maybe they also have less responsibilities, maybe family responsibilities that older people. So I think young people have the potential to grow more and to learn more than maybe a more established researcher that is doing more other type of work. So I think young researchers are doing great science today, and so I think that should be valued, instead of because when you apply to grants or you apply to projects, usually they give the project to more experienced senior professors, because they have a lot of experience. That I agree that experience is something that is very good, but also the capability to think new things, to try new things. I think young people also deserve having this part of the fund to be able to accomplish their projects and to do great things for our planet.
Yeah, absolutely. And I think your work goes to show excellently that, given enough support, younger researchers can do amazing work as well. So this divide between established and up-and-coming researchers is counterproductive probably to science. Is there anything important to you that is not included in your resume, any sort of personal achievement or something of that nature?
Well, I think I'm a very hard-working person. You don't put that in your CV. In your CV, you put your publications, your achievements, but there is a lot of work behind. So I think hard work is something that defines me, but also any researcher and professional in any discipline that is passionate about what they do. And I think that also hard work is key to be successful in any discipline.
And do you have any advice for young researchers in your field or in general?
Well, I think science is wonderful. You get to choose the topic that you are more interested in, the collaborators you want to work with. Also, every day is different. You learn every day, and it's also very satisfying to be able to see how the discoveries you make are turned into action and are helping other people. So I think I would encourage everyone that is interested in science to become a scientist and enjoy this journey.
Thank you so much for these lovely words to end on. I see there's no additional questions from the audience. So once again, a deep round of applause and congratulations, not just from myself, but from everyone in the Letten committee and here as well on Zoom. We hope that you continue on your journey, as scientists, science communicators, and as citizens. We truly appreciate the nature of your work, and we hope that you continue doing great things in the future.
Well, thank you very much, and it has been a pleasure.
Thank you. Thank you. Bye-bye.